Hey physics class, how's it going? So hopefully you've looked at some vector stuff, some advanced vector stuff from the last two videos. For this one we are going to start up with projectiles, and so I'm going to do an intro of to what the heck projectiles means and how we're possibly going to kind of answer these questions. How do we first set up these questions, look at it and understand these questions. So what projectiles mean, it's basically one of these three options behind me, but I'll just talk about it first. It means basically that you are throwing something, okay, with an initial velocity, usually sometimes with an angle. This week we'll have no angles, but basically you're throwing something either off a cliff or from the ground to the sky, and then from there, basically gravity, like the acceleration of gravity, is doing all the work, and we can figure out everything else off of that. So we can figure out how far it goes, how much time to take, the velocity at the bottom, all these different kind of things. Basically, because once you have that first initial throwing, you're gonna have that initial velocity. After that, everything is done just basically by gravity, by time, by distance, and so we can use our kinematics formulas to figure that out, okay? So here are three different types of questions. We're only gonna be looking at one this week, and then the other two will happen next week in our projectiles part 2. So we have these three possibilities. Either you're on a mountain, okay, or a ski slope, or a hill, or something that you're elevated on. And then there's two parts. You could have it being thrown just horizontally, which means just in kind of our x direction. So if you throw something straight, basically this way, or if you throw something at an angle, okay? And so the only question that we're actually going to look at just this week, part 1, is going to be where we're elevated on something and we're throwing it just horizontally, okay? Just to make things kind of easy and nice to kind of get into for part 1. All right, so these are the only questions that we're going to look at this week. Next week we're going to look at these two options where I'm going to put a blue, where we're going to start adding angles. Okay, so part 2 is going to look at, sure, if we're elevated and if we throw at a certain angle, what happens, as well as if we're on the ground and we throw at an angle, maybe we're throwing over something or maybe we're throwing at a target, but basically figuring out everything that happens with this. Okay, so we're on the ground and we have an angle. So basically next week is going to be projectiles with angles, okay? Where today and for this week we're going to look at projectiles just thrown horizontally, okay? All right, let's keep going into our intro. So let's actually get rid of everything else and let's get going on to just this. So let's say Mr. Russell throws a ball at a certain speed. Let's give it 10 meters per second that way, all right? What's going to start happening to the ball? It is not going to stay straight and fly forever. The reason is because of gravity. So it is going to start going down. And it is going to kind of make this kind of shape. Why is it going to make this kind of shape? Well, again, gravity is an acceleration. It is going to consistently change and continually make more velocity in our y direction, okay? And so projectiles are known for having parabola shapes. What a parabola shape is, basically it's going to go up and down, or basically if you're at the top of the hill, it's just going to go down and make that parabola shape. Okay, so that's what projectiles is doing. All right, now here's an interesting concept that I talk about in grade 11 a little bit, but don't have to. Let's say you just drop a rock straight down, or if you throw it just horizontally. So you're not throwing it up, you're not throwing it down, just straight horizontally. The time that it takes to land will be exactly the same. Okay, and that kind of sounds weird. If I throw it straight, it's going to land so much farther away than if I just drop it down, which is absolutely correct. It is going to land quite a bit farther away from where it lands. But if we think of, and this is what we're going to have to do a bunch, we have to break apart our actual throw into an x and y component, which is why we just did vectors, talking about components, about x and y. We have to be able to break this apart because we are going to have a velocity in the x direction and we have a velocity in the y direction, up and down. Gravity only affects the actual y direction. It only brings something back down if I throw it up. Okay, so it's actually only going to affect the y direction of my velocity. So if I look at this velocity, 10 meters straight sideways, my x velocity is 10, but my y velocity is 0. And so that's why if I were to just drop a rock from straight like this, or if I were to throw something straight sideways, acceleration is going to bring it to the ground at the exact same speed and in the exact same time. So that's kind of an interesting fact and something that we're going to have to use this week. All right, we're going to have to keep continually kind of breaking this apart. So there's kind of an intro into like, how do I break this apart? Not how do I break this apart, but again, just our time factor. Our time factor is going to be this. So if I wanted to figure out the time, even though I threw it at a velocity this way of 10 meters per second, if I just wanted to figure out the time, let's say Mr. President threw a football 10 meters per second straight, how long would it take to get to the ground? I actually don't even need this 10 because my y velocity is 0. So I have a distance, let's say this, usually I'll give the distance of this, in this instance I will. Let's say we are 50 meters up on something. Let's say I have a distance of 50 meters high. My VI is 0 in the y direction, and so usually this is how we're going to kind of put it. We're going to put a VIY is 0 meters per second, okay? My velocity initial in the x direction has something, but my velocity initial in the y is 0. Acceleration is always 9.8, and it's helping the ball, it's speeding the ball up, so it's positive. And then I can figure out my time. I can tell you right now, the formula that you're going to have to get used to this week, a bunch, it's not the most fun formula, is this one. Distance equals VIT plus 1/2 AT squared. You are going to use this formula quite a bit for our starting horizontal projectiles, okay, and even technically when we get into the other projectiles as well. And the reason is because we don't always get the velocity final, and so we end up using what's the only formula that does not have VF in it? It's this one. So we're going to have to play with this one a lot. We can figure out the distance, we can figure out the time, we can figure out, like, you're not ever going to figure out the acceleration, but we can also figure out the initial velocity possibly in that kind of sense. Even though for this week, our initial velocity is usually going to be 0 in the y direction. Okay? So there's our little intro to projectiles. What does projectiles mean? It means it's like we're throwing it off of something elevated or something angled. For this week, it's just going to be throwing something horizontally off of a cliff or hill. And then this is how we're going to break it down. We're going to have to break it into our x and y components every single time. All right? In the next video, I'll kind of talk about a little bit of our graph in the sense of like how do we plot this? If we were to plot this, what would happen in the x and y direction? As well, I'll go through one first start question, and then for the third video, I'll go through 2 or 3 more questions just to kind of go through those. All right, thanks, class.